So, got a handful of supplies here. These are intended to split the HDMI signal from my computer, my screen that I built. The dual iPad screen. The idea is I built one for this workbench. I also want to build one for my desk, and I don't really need separate images, so I'm fine mirroring them. So I bought these HDMI splitters. They were cheap. Hopefully they do the trick, but I'm just going to feed the two HDMI signals because each panel gets one separate signal. So I'm going to feed the two separate signals in, get the two split outputs, and I'm going to send one pair of outputs to the workbench, the other pair of outputs to the desk. And the main reason for doing it that way, or the main reason I have the desk, is because I want to get set up to where I can work with taller objects. This workbench, when I built it primarily with soldering in mind. So working on circuit boards, small robots, things like that. The workbench height is not really all that impressive. I've got about 7 inches of height. That's about 17, 18 centimeters between my second shelf and the actual work surface. Now I've got about, what is that? I've got about a foot, 13 inches, about 35 centimeters or so of space from the front of that middle shelf to the edge of the workbench. However, that's not always enough space for larger devices. So, if I'm restoring a calculator, for example, the big 1960s type things that I like to work on, some of those are huge. They won't fit on this workbench without them sticking way off the end. It's just not practical. So I am trying to get that desk set up as a secondary workspace. So that I can work on larger things there. As a side note, I have also found some rather interesting cameras. See if I can find them here. Give me one moment. Let's see. So I found this camera. I don't know how good the quality of this actually is, but the actual application for it is essentially, I suppose you could say, industrial monitoring. It's supposed to be a 4K camera, although looking at the specs, I think it's only 4K to storage. I'm not sure. Oh no, it says video output can support 4K 60 frames output. I think it was a different camera I was looking at that had that limitation. Supposedly it's a Sony sensor. It'll simultaneously output over USB-C and or or USB 3 rather, and HDMI. So in theory, I could feed the USB to the computer and use that as a source in OBS, for example. Let's see. And if I wanted to, I could probably have something like an HDMI switcher, so I could switch into one of the screens on my workbench and just have that as a live feed. Because I don't know how much lag there would be going through the computer. One of the reasons I want this camera is I want to be able to zoom in on things and use it almost kind of like a magnifier or microscope. I don't know how far it zooms, but I found another camera that has like proper microscope lenses. That one, I don't like the limitations of the video output, but I might look at just getting the lens. But I'm thinking of getting, like a pair of those cameras, one for the workbench and one for the desk. I think those would be useful. I don't think they have audio, but I can always just get a separate microphone. That's perfectly fine. So that's kind of some of the plans there, I guess. Don't know when those cameras will happen, but it'd be nice to upgrade from, the old iPhone. So as far as that goes, that's kind of where things sit there. Oh, of course. Of course, Windows wants to update. So all these little right angle adapters, they're meant for various monitors that I've picked up, so I can run cables from the sides to the back, because I don't want a bunch of cables just looped back. These are at least a little lower profile. So with this monitor, I actually made the case for this. I don't know if this is gonna be very visible, but I will try. It's just literally layers of plastic sandwiched together, drilled and screwed together. There's some clear plastic, or kind of translucent-ish plastic there to make room for the buttons. I mean, it's very, very homemade, but it works well, and I like it. As good as this works, and it does work, as good as it works, I found that they actually just make pre-made metal enclosures for those iPad LCDs, and I got a pair of those iPad LCDs waiting for me at work in the recycling pile. So I will be bringing those iPads home to disassemble. Basically, I extract the LCD panel from them and throw away the rest of the iPad. That will go back to the recycling pile. And those will end up becoming my second set of displays. So I'm pretty happy with how all that's coming out. And then these here were a bit of, honestly, these were kind of unobtainium. I am shocked I found these at all. What these are tiny dot matrix displays. Probably just show the whole thing. So I'm trying to remember what the model is on these. These are HCMS-2003s. They are very small. For size reference here, that isn't. Oh, I don't like that. These ones are chipped. I never noticed that. Yeah, I really need to test these to make sure they actually work. I know they're basically salvage stock. I don't like that that's chipped, but it's just a glass cover plate, so I'm sure it's probably fine. So these are about okay. About 11/16 of an inch long, and for the rest of the world, let's see, (17, 18 millimeters long. Only about 7 millimeters tall. They're very small. The reason I got these displays, they're used in the Hewlett-Packard HP 9825 calculator. When I say calculator, I mean computer. And yeah, they basically marketed a bunch of their early desktop computers as calculators because they knew that at the time in the mid-70s, it was much easier, red tape wise, to requisition a specialized calculator that's, specific to your industry than it was go to management and say, hey, I would like a computer just for me. The concept of a personal computer just didn't exist back then. And so there really wasn't any good way to request one that didn't go through all sorts of red tape, especially with like government and any kind of government or military type thing. That was the worst if you wanted to requisition a computer back then. So they literally called their computers, their desktop computers, calculators. That's how they got around it. But I don't know. I thought that was pretty interesting. But they have red displays, red LED displays, and they use the red version of this part, the 2001. I'd heard of a prototype HP 35 pocket calculator that had been made using a green LED display. And of course, it never went into production. Even the fact that it was made at all is, I think, hearsay maybe. I think it exists. I'm pretty sure I've seen photos of it, and I don't think they were faked. So these are green versions of the displays used in the 9825. And I got these displays just because I like green displays, as you can see. And I just want to see what a HP 9825 looks like with green displays instead of red. So this is just a little very simple mod project I'd like to try someday. I think it'd be fun, assuming these displays even work. Like I said, these were pretty much unobtainium. They're an already obscure product that really was only made during a portion of the 70s and 80s, and I suppose they still made them into the 90s for very niche applications, you know. But yeah, I'm amazed I found these at all. So we'll see if they work, and hopefully they do. And I will be very sad if they don't. Mainly because I spent $25 per display. Yeah, I don't even want to think about it if they don't work. Alright, so back to this thing. Try to find a spot where there's less glare on the screen. So I built this last week. I streamed for about 11 hours building this thing, and I had to take the VOD down because I left my shipping label right on top for the first 20 minutes of the stream. Oops. So I won't make that mistake again. So the way this thing works, when you power it on or reset it, it's going to show the basic information, its version, what it is. So this is firmware version 26. They're already on version 27 or 0.27 since I bought this kit. The guy who created this is just unbelievably talented. He just does not stop developing this thing. But to give the overview of how this thing works, this basically has this zero insertion force socket. Flip the lever up, parts literally just drop in. Flip the lever down, and it locks the leads in position. If you notice, there's a bunch of resistors and diodes here. There's basically banks on every single lead. These are all protection diodes and current limiting resistors, and they all lead to inputs on the microcontroller, which is an Atmega 2560, I believe. And through these, it's able to read every single pin of this socket. Additionally, there's outputs that control all these transistors, as well as these two relays and this switching. This is essentially a solid state relay on a chip, so it's several switches that are electronically controlled. But what all this does is it's turning different pins on and off, or in the case of the relays, turning certain power supplies on and off, and in the switching chip, it's switching different power supply sources to different pins. And so the way this works is you've got all these different menus. So you have static RAMs common, static RAMs uncommon, Cypress branded static RAMs, dynamic RAMs common, uncommon, first in, first out. This is a very old style of memory that kind of predates regular RAM. Back in the very earliest days of memory, you used to have what were basically extraordinarily long shift register chips. Basically, you would have an input and an output, and you might have, say, 48 bits or 128 bits or 256 bits of registers. And what you do is you would feed data in to the input, and it would kind of travel bucket brigade style down from one register to the next until it reached the output. And to read a specific memory, you just had to wait for that memory's turn to come back out the chip, and you had to then refresh it by feeding it back into the input, or else that memory would be lost. If you want to do processing on memory, you would have to read that memory out at its turn, do the processing, and then feed that memory back into the input at the appropriate time. It was a very convoluted way to do things, but that's kind of how a lot of the early memory applications worked. You had a lot of what were known as bit serial processors in those days. So instead of having, 8 bits or 16, 32, or 64 bits, you had 1-bit processors that would take data 1 bit at a time, and it would sequentially build up a number that consisted of X number of bits. You'd feed that number in as a serial sequence of data 1 bit at a time. And these were the types of memories that were used in those things. I understand the general concept of how such a thing works, but the timings of that just absolutely warps my brain. So it also supports EEPROM, that's electrically or erasable programmable read-only memory. Programmable read-only memory and ROMs, so mask ROMs. Second set of them. Logic covers your general purpose logic chips, reconfigurable logic, miscellaneous stuff. You can also define custom chips. In the manual, it shows how to generate your own chip definition. So if there's a chip that you want to test and it's not built into this, you can add it, which is actually kind of neat. There's a programming mode which lets you so I have this memory card reader. Right now it plugs in so it sticks up, and I'm just gonna very simply modify this so it sits flat like that. But you can load ROM data onto a memory card and program that onto a programmable chip. And then there's the service menu, so you can configure the thing, and then it loops back to the statograms. But let's go to logic. So I'm gonna hit OK. So we're gonna do, let's see, we have 7400 series logic. We have 7400 from the 300 range and up logic. Now this is a 74154. So we actually don't need to go quite this far, but it actually goes into the 600 logic, the 7500 series, the 4000 series, the 4500 series, some miscellaneous, more miscellaneous, Soviet chips, Soviet CMOS chips, and a bunch of miscellaneous stuff. It also can do programmable array logic chips. If you tell it which pins are inputs, which are outputs, and which are unused, it can actually go through and perform steps to actually analyze what the logic configuration inside that chip is, even if the chip has been set to not allow you to read out its configuration data. So that's kind of a neat feature. Well, here we go. This is how you would set it. You tell it which pins are inputs, outputs, ground, the 5 volts, I'm gonna go back actually. Okay, I had to reset to get out of there. But yeah, so what we want to go into is the first set of 74 series logic. And obviously if we go one at a time, it's going to take a while to get to 154. backwards, it goes, you see the exit, and then it goes to 74,299. We're literally right in the middle either way, so it don't really matter. But if you hold the button down, it will accelerate after a while. Alright, so now we found the 74,154. What this chip does, it has 4 inputs, and you put a binary input into that. It then has 16 outputs, and it will select one of those outputs based on the binary input. So essentially 0 through 15. All zeros will select output 0, 0, 0, 0, 1 will select output 1, so on up to, 4 ones will select output 15. So it's a simple binary selector chip. If I hit OK to test this, it's going to go through, it's going to do 16 passes where it's testing all the different combinations of inputs, and it's going to verify that every output is correct. So in the 16 test passes that it did, every one of those tests worked. So that's good. Now, if I hit OK again to test, you'll notice 2 things. The activity light will come on, but also this VCC. This is the power indicator. And so is this, and so is this, and this, and this, and this. This has multiple power supplies. So this is your main input. This is on whenever it's on. This board here is an add-on power board. So stock, this thing can be powered with a barrel jack, and it's got 2 basic supplies, a plus and a minus 5 volts. Actually, what it's got is it's got a 5 volt supply and an adjustable supply. Those do get a little toasty. Not hot, but I can definitely feel some heat. But anyway, what this add-on board does is it adds additional power supplies. You got 5 volts, you got negative 5 volts. You've also got 12 volts and negative 12 volts being generated by this module here. The negative 12 volts, the 12, the negative 5, the 5 are all available on this header here. So if I wanted to put in a DuPont style jumper there, I could have a probe with different voltages. And what that also means is I can have adapter boards here that require voltages that are above and beyond what the built-in switching can switch. So say I need to test something that has a negative 12 volt input. I can tap into the 12 volt here, plug the other end of that jumper wire into an adapter board, which will then provide 12 volts where it needs to go. A lot of the power switching is done built in, but there are a few things that require some manual interventions. Some memory chips require power on certain pins, like this selects pin 8 or 9, pin 10. This one selects for pin 9. It's just marked with different, memory chip model names. So you can set these jumpers to get additional power configurations for some somewhat unique chips. This header is for flashing the firmware. This, like I said before, is the memory card interface. So I can actually plug this in if I wanted to. And that would give me access to the memory card. In fact, if I go to... okay, I hit the wrong button. So it was expecting a 7400, which is a 2-input NAND with 4 gates. Well, it's obviously not that. So when it did the test expecting a different chip, it failed. And that's actually normal. I'm going to pull that out. So I'm going to go into the service. So I hit info. It'll show the firmware version, different details. There's a self-test. Okay, SD card. Okay, so this tells it whether to look for the SD card or not. So if I was set that to 1, it would be looking for that. Right now I'm going to leave it off because I don't have anything on this SD card. But what you can do with this, say I put a ROM chip or an EEPROM or something like that in here. There's a database file that I can put on a memory card that contains the checksums of every known ROM, EEPROM, you name it, that has ever been recorded on this device. And what I can do then, say I was testing, let's just say I was testing a Commodore 64, right? I could take the ROM chips off that, put it in here, test it, and it would be able to read the checksum of that chip, compare it to that database, and say, this is a Commodore 64 upper ROM, and it passes. Or it could say that it's, the lower ROM, and that it passes. Or it could say that the checksum doesn't match. So that's kind of a useful tool. It's a very easy way to determine, does this work, does this not work? If you have one plugged in, like a ROM or something, if you hold down the OK button for a moment, it'll actually dump it and save the ROM file to the SD card. So that's also pretty cool. So it's a pretty useful device. Does a lot of different things, and I'm pretty happy with it. I guess I didn't finish with the LEDs here. These are just representing different power supplies. So this is 12 volts, 5 volts, and negative 5. And looks like I am full of Pokemon here. Just take a quick break to evaluate these. Looks like all junk. So I will transfer them all. I will check those actually. All right. I will leave that be. It's a little beat up and worn, but I like this water bottle. It's my capacitor. As you can see, it's just a bigger one. So I'm pretty happy with this device. So I mentioned adapter boards. So this is one of the boards, and okay, we're all good. So this is a Commodore 64 cartridge adapter, and it does exactly what it sounds like. You insert this, secure it in place with a lever. Now I can plug in a Commodore 64 cartridge into this, and I use this switch to read the upper part of the ROM, the high ROM, or the low ROM. And I can dump Nintendo 64 cartridges with that. That's pretty cool. I like that. I'm also going to be utilizing this foam to protect the leads, because they are very fragile. So that's one. But I have a few more. I'm gonna unplug this for now. In fact, I'm gonna move this out of the way entirely. So originally I bought these because these are much like on the main board. These are ZIF sockets. So you put the part in, flip the lever, clamps down on the part. The pins on these, these are cheaper ones than what I bought for that. Buying one, you know, if they're expensive, I mean, it is what it is. They're kind of, you know, you just buy it once. With these adapter boards, I need one for every board, so I bought some cheaper ones. Only problem is they used about the smallest sized hole on these adapter boards for the chip socket. These pins are rectangular and wide, and they do not fit. So I can either do what they recommend and just go with sockets, which I mean, I can do that. What you're supposed to do is use these things. Oh my goodness, they are really in there together. So normally you would just load these with this. And then whenever you plug a chip in, you plug it into these. That's fine. That works. I probably won't ever program enough chips to even wear out these sockets. But it was just one of those things where it's like, but this is nice, you know? And yeah, buying cheap has bitten me. So I could fix this a few ways. I could take a file and just try to narrow all of these pins down a hair, which would work. I mean, nothing wrong with doing it that way. It's just gonna take time and effort, and it's a lot of time and effort that I don't know that I want to put into this. I mean, I give it a shot, see if it works. Of course, I got one of these, which is kind of a neat socket. It's the same as these, basically. However, the big difference, well, aside from the fact that I don't want to go in the holes, it has these flip-up tabs that can eject the chip. Obviously, this isn't the right size chip, but if I was to put a chip in there, when I flip that, it's going to lift the chip, making it easy to remove. So I could use this with this one, but I've only got one of these. And the other thing is, these things are as expensive as the proper retail versions of these. So I'm not really saving anything going with these. It's just, at least they fit, you know? So, but these have the same limitations, being that these are very precisely machined holes. So if there's any wear and tear, that's kind of it for it. So that's a possibility. But again, I don't see myself putting enough wear and tear for that to matter. The other possibility, so these are meant to go underneath and be the pins that plug into the board. So these stick out underneath. If, however, I were to say, let's see, let's say I put some in to the top, and then sort of align this on top, I could theoretically solder it on, just solder each pin from the side. It would be more effort, and it would be sitting, you know, an extra bit off the board, but I mean, it would technically work. And it would let me use these sockets easily. It wouldn't be a great expense having to use some rows of this stuff. I could theoretically use, oh, where is it? Theoretically, I could just use this stuff goodness. So that's kind of why I don't want to use this for just the plain chip. I could solder these in place, and since there's a cup here, these pins perfectly fit into the cup. And I could solder to the surface of it, but it's, again, it's not as ideal as this. And these I only have specific need for. So, yeah, it's a thought. All right. Yeah, I've kind of got a similar situation with this. I don't know if... At least this one uses wider sockets, so these may actually fit. Although I'm going to have to do some drilling on this board because this is also not a standard part. This is kind of an uncommon piece here. This is a single inline ZIF socket. I didn't even know these existed until about like 2 weeks ago. So I really want to utilize this, even though it's way overkill for the application. It's also a 32 pin socket, and I need it to be 30 pins, so I'm probably gonna have to like mask some of these, but we'll make it work. So let's see, where was I? This was the big one. All right. Yeah, I don't know if these will sand even fast enough to make a difference. I'll give it a try. Doesn't hurt to try one. I'm gonna sand both sides. Certainly inserting further than it did before, but it's still a very tight fit and it's not quite right. So try continuing. So obviously these unusually wide pins are less than ideal. Yeah, also the pins kind of slide up and down for whatever reason. That reason being that these are the cheap versions of the socket. I have gotten what I pay for. Let's try the other end. So that's obviously not ideal. I really do not want to have to do this with every single one of them, but if it works, then I'm probably just going to suck it up and do it. Although I might not necessarily solder every single one of them on camera if I have to do this for every one of them. probably help to, you know, put it on the right side. Okay. I do feel like they insert deeper. I might try soldering these with the gap here. I don't know how visible that is. The pins are going part way through, but not all the way. I feel like if I sand this a little more, it might actually push through. So I may just keep trying this. If I can make it work, I'd rather just have it work then, you know? Even if it is a little extra effort. Oh, it is not fun. Oh, man. All right. I do think there is some progress being made. Shows me what I get for buying cheap parts. It's definitely better. Like, those are pushing just about all the way through. Like, I could probably solder it like that if I really wanted to, but I think I'm going to give it at least one more pass. because the holes are so tight, it's actually a little hard to tell if the pins are pushed up or not. I can kind of tell from the top end of the socket, but I'd rather they not be. It's honestly hard to tell. I won't make that mistake again. Alright. It is crazy how easy it is to bend these pins out of shape, which probably speaks volumes as to the actual pin strength. Okay. think that's it. It actually went on. I may never get it off again, but it's on. And of course, I actually do want to take it off because I need to install these first. Wait, not those. These first. And interestingly enough, those will actually keep it from sitting completely flat. But getting it put on does two things. It ensures that we've actually pushed the pins through to the point where they'll actually go through properly. But it also means every time we push that on, it kind of deforms the holes just ever so slightly. And in this scenario, we want that because, yeah, we don't want to deal with we just don't want to deal with it not fitting. So if we can just get the board to ever so slightly deform to accommodate the pins, that actually helps us. I mean, if the fact that I'm having to literally pry every pin loose here is any indication, I mean, it's a tight fit. You can kind of clearly see that, but that's fine. We call this making do. So yeah, by pushing the pins through, we kind of, in a sense, use them like an awl and kind of force the hole just a hair more open. And that's fine. We want that, because the next time we put the pin through, it'll just be ever so slightly easier, because it'll have forced the corner slightly rounder, and it'll have forced a slight corner into each of these. You know, we basically put a square peg into a round hole and made it fit. So I can feel how rough that is. So this will work. I'm alright with that setup. It was a fair bit of extra work, but it'll do. But we still need to assemble this board. I think all the parts are right here. So I'll just have to verify that, but okay, so get the file out of the way. is actually a PAL configuration for a chip that I used to use at my old job building electric motor controllers. And if I can ever figure out how to use the PAL testing function, since I know the output of this chip, or since I know the configuration of this chip, I should be able to see if I can get that PAL analyzer test to work. So I'll use this as my reference for that. Alright. Well, I'm hitting the wrong buttons here. Alright. So we want the assembly. So this is our 30-pin memory module that we'll be making at some point. There are a lot of adapters for this thing. So this is my Commodore 64 adapter. I bought the plug for the VIC-20 adapter, but I forgot to get the adapter board, so I still need to order that. I've also got plugs for the Atari. Obviously, as you can see, some of these adapters are assembled using the machine pin sockets, and sometimes they're made with ZIF sockets, but so normally they should fit, but like I said, I bought cheap ones and they have those wide rectangular pins instead of the proper round ones, so that was my bad. Alright, so this is the one we're working on right now. So these are the parts we need. So the 22 microfarad capacitors, the 1N5817 diode. Let's see. the DC-DC module, the 2 transistors. Yeah, I should be able, I think I got all these parts out. Is the 2564 adapter. Yep, that is the 2564. Alright. That is our diode. We need one of these. The 8550, I believe, is the replacement for, let's see, that's the MPSA 06. So yeah, the MPSA 56, they're not available. And so, these are the replacement, the 8550. And I did confirm last week that they are drop-in replacement. There's no different pin configurations, so those should be good to go as well. This is the other transistor. That's the MPSA 06 or 06. These are end of life, but they are still available. However, the ones with the unformed leads are not available. So I have to actually unform these leads so they'll fit this board properly. Okay, this is the 22 microfarad capacitor, and I need 2 of these. Not used. Not used. I don't think that one's used. Okay, 4.7K. Do use these. Not used. do use this. We use that. We use this. Apparently we don't use that, which kind of surprises me, but all right. We will have some random socket pins here for connecting power with. And of course, we're going to have our 4 pins for the DC power module as well. That will become apparent once I have that installed. So this power module, this is a pre-made step-up power module. It's like a buck or two off of like Amazon, AliExpress, wherever. It's one of these mass-produced cheap circuit modules. Let's see. All right. So first off, let's get our resistors measured out here. We'll need one 10K resistor. I'm just going to put these in order. I'm just going to turn on my soldering iron right away. We'll need 2 of these 4.7K. And 1 each of 1K. This is 3.3K. Again, we need just one of these. Yikes, I could use a few more bits upstream here, I think. So I considered using this part, but since I was able to make the ZIF socket work, I much prefer that. Just get the fan a bit closer to the work here. Alright. So I'll bring this thing out. You know, now that I've seen the display on that thing, I have half a mind to see if I can find this LCD module as an OLED too, because man, that OLED looks good. Alright, so this was pretty sure that was 10K. Yep, 10K. I just like this thing as a sanity check, you know? I will admit my vision isn't the greatest, so sometimes having a clearly readable screen just means so much more than trying to remember some color code. I gotta remember, the guy that designed these boards decided to space these things very tightly. So I gotta put a pretty tight bend in the component. Alright, so 10K goes there. Oh my goodness, even that almost wasn't enough. Actually wasn't quite enough. It'll work, but I gotta kind of force it. So, with spacing like this, it's more ideal for this style resistor. It's literally like half the size. Let's see. That would have been the 4.7K on the list. For 1,700 ohms, yep. Alright, so you can see these are much easier to bend at that narrower lead spacing since they're physically smaller. I still made this one too wide. I don't know. I don't care. I can force it. Alright, so the yellow is on this side. You don't have to put these one way or another, but I just like to orient all my resistors more or less the same. It just looks nicer that way. There's no obligation to do that. It's just, you know, wanting it to look nice. Okay, next in the list was the 1K. Verify that. Oh, this is the 3.3K. Well, I'm glad I tested that. Okay, so that's the 3.3K. That's why we double check. The upside to these small resistors is they'll fit just about anywhere. The downside is you really gotta squint to see them color bands. Okay, this is the 1K. This should be the 330 ohm then. So if I look closely, you can see it's orange, orange, black, and then I think that's black and brown, and that's indicating the tolerance, and there's an extra color band when it's the higher tolerance like that. Yeah, the significant digits is the ones represented by orange, orange, black. This is our diode, and this does absolutely have to go in the right way. Diodes function in a way that requires their polarity to be correct. So that is just Pokemon stuff. I gotta fix the handle on these things. I'll use this one. This is my really crazy sharp one that will absolutely trim the pad right off the board if I'm not careful. This one, the leads don't even go flying because they're so cleanly cut through that they're not, you know, yeeted. Yeah, I'm absolutely not kidding when I say I've unintentionally cut the pads right off of a board using these things. Alright, so this is the 8550 and this is the MPSA 06. So the 06 goes here. The 8550 replaces the MPSA 56 and that goes there. Capacitors go there. And what this board specifically does, it's a EEPROM programmer. Specifically, the model EEPROM that it programs requires a very high programming voltage, much higher than this chip tester is normally able to make. But that's kind of what's nice about this thing. With these adapter boards, you can just add additional power supplies if you need it. There's no real limitations as far as how far you can take the tester, because all it's doing is feeding, you know, bits in and out of a socket. If you need additional power supplies or you need to arrange the bits in a slightly different way, you can just do that with an adapter board and you're good to go. do think this thing got magnetized at one point, so not ideal. Sometimes the leads will stick to it. I'm just going to touch up all of these joints. So now I get to install these sockets, or these pins rather. Alright, so I hope I didn't pull that off screen too much, but that was a lot of three-handed soldering with one hand. Alright, so this is ground and VCC, which is the power rails here. You can actually just probe off of these, test them. The idea is you can measure off of these points. This is supposed to be set to about 25 volts. This is a boost power supply. So you've got ground and ground, voltage input, and 25 volts output. And the idea just straighten some of my parts here. The idea is this module provides at 25 volts. So I'm gonna very quickly solder that in. They have these very oversized holes, but that's fine. Just need a little more solder to fill it all in. Alright. And there we have it. The power supply is done on that board. So now we need to solder the leads that go on the bottom. The simplest way to do this is just get solder in one end. And then once that's inserted, we reflow that. Do the same thing with the other side. Pull that off. Get a little fresh solder on here. And we will make sure that it is sitting flush and level. Is very much not flush or level. One thing that can be done, since this is all standard spacing, is insert some crossways. That will ensure that they are level and aligned. Now, now that they're secured on the one end, I will secure the other end. Make sure that they're tight. You can secure an adjacent set of pins. Make sure these are reflowed with fresh solder. Now, I can remove these. And solder the rest. So now, interestingly enough, when we go to insert the ZIF socket, these pins will actually prevent it from inserting all the way down, though we did confirm it's now possible to insert it all the way. We just won't need to, since we went and filed it. That filing was pretty extreme, but hey, whatever works, right? So I find the thing. There it is. Just want to clean this up because this is going to be covered by the ZIF socket once it's installed. So I don't like how much solder is there. This is just 99% isopropyl alcohol, which is pretty good at removing soldering flux. Alright, so final step of this one, we get to insert this. Some of these pins just do not want to line up. I know they'll fit because we fit it before. Okay, it's in. Right, so now this is gonna be fun. I want to make sure each pin is pushed all the way down. Since literally forcing the things in means that they're all pushed up as high as it can be, so just making sure that they all sit flush. Oh, that would have been just great. I almost broke that one. Yeah, get this far and then break it. Go figure. Oh, that one is actually kind of messed up a bit. Great. Is this socket actually damaged? You gotta be kidding me. Well, this is less than ideal, but I think it's fixable. Some of the pins, or the sockets rather, not pins, are kind of misshapen. So yeah, this is just bent the wrong way here. So I think that's from repeated bending of the socket, but like I said, that's easily fixed. Yeah, this is actually pretty easy to fix. Actually, now that I know how easy it is to service this socket, I don't quite feel so bad about its cheapness. I do wish it were gold plated, but you know, beggars can't be choosers, and I chose to not spend big money on these. These are sockets that I will only use very occasionally, and I'm fine with that. These are actually really easy to service. Alright, I am happy with that. Could have just popped this top and pushed them all down. That would have been way easier. Okay, so stubborn going back in. That's very annoying, but oh, really? Alright, so there. That is back. Anytime you're screwing into plastic, it's wise to screw backwards until you can feel it engage the thread. Otherwise, there's a good chance you just end up cutting new threads every time you put the screw in and slowly ruin the threads. Alright, I'm happy with that. It's a little loose. Oh, you know what? I think it's just too tight. No, that's just how it is. Again. What do I get with cheap ZIF sockets? I'll take it though. So I do not need to worry about soldering, you know, one pin first. This thing is so tight in there it ain't going anywhere, so we're just soldering it. I'm going to feed just a bit extra solder. Hold the soldering iron on a hair longer, so I want to make sure that it flows through to the other side. Those pins are pretty good chunks of metal. This will be done with the first adapter, or the programming adapters anyway. So I ordered just the Commodore adapter, the RAM adapter, and then these programming adapters because I didn't really expect to need to test a lot of the other chips. Some of the adapters are very, very niche things for testing very niche components. So I'm not bothered not having every single adapter. That being said, there are a few adapters I kind of wish I'd have grabbed, so I'll probably grab them at a later date. There's a frequency generator adapter. There is a multi-vibrator adapter, which seems to allow, I don't know, like, I'm not quite sure how that one works, but considering I'm probably going to be utilizing quite a few probably one-shot multi-vibrator circuits in my Kerbal Space Program instrument panel. Basically, I want toggle switches, but I want them to operate like push buttons because the game expects keyboard inputs. And with keyboard input, everything is push button. So you tap an action group to turn it on, you tap it again to turn it off. That's obviously not how toggle switch works. I could have gotten sprung toggle switches so they'd be in one position at all times, and you could push it and it would spring back. So it would operate like a push button, but it would be in toggle switch form. But I didn't want that. I want genuine toggles. You know, I want these to actually change states. And so what I'm opting for is I want to attach a multi-vibrator circuit to each toggle, so that every time it changes states, it produces a pulse, but that pulse will then end. You toggle it the other way, you get another pulse, and that pulse ends. So you get the effect of a push button, but only when the state changes. I'm going to have another button on the control panel, because obviously I want the toggles to have some sort of like a universal, one way being on, the other way being off, indication. But that doesn't work when you use your switches like push buttons. So I want to have a toggle inhibit, basically a button or switch that I can press or switch that will make all the toggles stop registering. So let's say I'm in one vessel and I have action group 1 on, and say that's deploying solar panels. Well, let's say I switch to another vessel, and that vessel, maybe that one has action group 1 off, but the switch is in this up position, and I don't want it to be that way. So I can press the inhibit toggle button, flip the action group 1 toggle, and it won't generate a button press. So that way I can switch to a vessel, and say there's an emergency. I'm switching to a vessel because I have to do something immediately. So I switch, and this is off, and I flip it, and now it's on. So I've done my task, and I can do that task immediately. I don't have to wait and configure things. But now that I've got things resolved, I can say, alright, I want to reconfigure this, inhibit toggle, flip that to the position I want it to be, and it won't register that pulse. So that's kind of what I want to do with these toggles, and each one's going to have a circuit to do that. That circuit will also double as the switch debounce circuit. When you flip a toggle switch, for example, it's rarely ever a very clean signal. When you make that flip, you're going to get kind of scratchiness in the output, and that can register as multiple switches of the switch, to say an electronic device, that's monitoring it. And so a debounce circuit basically just makes it so that it cleans up that signal, so that when you toggle the switch, you only register it once, not 2-3 times. If you've ever pressed like an old remote control on something, or you have an old keyboard, and you press a key once, but you get like 2, 3, 4 letters out of it, that's debound, or that's a switch bouncing. The bounce circuit eliminates that. So the multi-vibrator circuit and the debounce circuit will be pretty much integrated together, and each switch will have one. So that's the plan anyway. Alright, this is one board down. I'm going to do a little bit of cleaning here. So there are some types of flux that are more corrosive or aggressive. The stuff that I use is actually called No Clean, like that's a brand name. Technically, you can leave it alone, and it's formulated that it's supposed to be pretty inert with electronics. But I still like to clean it up because it can be a little sticky. It just makes for a better looking end result when everything's cleaned up. Alright, so that's another one down. I'm just inserting those into the foam because those pins are very easily bent. So somewhere I've got a plastic black case that's thick enough that it should be able to accommodate a block of this foam, and I should be able to just insert a bunch of these in and close the cover. It's like a little 3M anti-static part tote, and it's perfect for this. Like, I don't think I could literally find anything more suited for this specific task than those containers. I think I have them in a closet somewhere. I'll have to look. I've not looked. Wait a minute. Not in a closet. It is right there in my parts shelf over there. I knew I had these around here. So, as you can see, it's just a simple container. And, I'll have to get thinner foam than this. This is too tall for this, because it will hit. But you get the idea. Like, this is pretty much the tallest one I've got because of the switch. And oh boy, it might not fit because of the switch. However, I could always mount strips along the edges too and insert them sideways and just have a bunch of strips. I could do that as well if something's too tall. These will absolutely fit. I got a little bit of room yet, so as long as I have foam that's as thick as the length of these pins, I should be fine. But yeah, something like this would be perfect for storing these. I like that. That's my plan. So yeah, definitely gonna need thinner foam though. For now, I'm just gonna keep, of course I'm doing all this off camera because I don't have a lot of, this is something that the desk would actually be beneficial for. I have a little more room to work with. So yeah, I'll just have to find thinner foam. For now, I'll just put these in the box with those displays. But yeah, this is what I'll use to store these. I bought this many years ago at a surplus store up in the Twin Cities area for a whopping 95 cents. So they're useful little containers. I can't complain about that. Of course, being anti-static or conductive, basically, they're safe for storing electronics. All right. Let's see. What do we got left here? So this looks like the most complex power supply. These three are pretty much almost all identical. Actually, so this one is essentially the same type of power supply as what we already built, but it's a different size socket for a different type of chip. It also has that diode there. These two, it's also a different size socket, but these power supplies are actually slightly simplified. This one has one fewer part, and this one has, oh no, more, even less. This has like 2 fewer parts. This has 2 fewer parts, and then 1 additional part added. So for whatever reason, you know, each power supply has got its own specific application, but they're almost identical. This one is a little more complicated. Don't know what the reason is for the different layout, but it's a little more complicated to suit its application. This is essentially 4 more of the same thing. So this power circuit here, these are almost identical to that. So I'm going to set those aside for now, because we'd basically be doing the same thing as those. I'm going to take a look at the memory board here. All right. I gotta find the memory board in the manual. I think it was, yeah, it was like one of the first pages in the assembly section here. So if we look at this board, it is arranged facing this way, which is not as ideal as we would like, given that we're trying to put a big connector on the other end of this thing. I'm hoping that the angle that this thing mounts memory modules to doesn't interfere with this, because I really want to use this. Alright, so basically this is for old 30-pin SIM memory modules. I don't really have any on hand, not without taking apart like an old Mac or something. Yeah, so that's how that is oriented. But now this. I need to drill some holes here. Oh, that is terribly off center. I hate that. Oh my goodness, that's terrible. Really? All right. Alright, we make the hole the right size by making it large enough for a ship to sail through. It's one way to do it. Oh, really? I think that'll work. I'm not gonna trim the leads on the end. I saw how easy the other one was to service. So I'm going to do the same and open this up. I can already tell this is just worlds better in terms of build quality. Don't want to wreck this thing, so I'm going to try and be very careful taking this apart. So far so good. I've just removed the two sockets from the two endmost positions there. Really hope I have a nut that'll thread onto this. I'd really like to secure it with the screw that's included with it. So, interesting background on this part. I didn't know these things even existed until very recently. I found one on eBay when I was searching for this part. I'd found these on DigiKey and I thought that's kind of neat, but they're barely any cheaper than the ZIF sockets, so I thought I'd look them up on eBay to see if I could find some slightly cheaper ones. On all of eBay I found one. That's it. One. And I thought, well, I mean, if I could get it for, it was at the right price. I was comfortable with the price, so I was gonna go ahead and get it. But then I decided, well, I'll look to see what else they have, and this popped up right away. And I'm like, wow, that's actually kind of a neat part. I want that. They also wanted $50 for it. I was not about to spend $50 for this, especially considering that that's close to the retail. Like, I get it if it's brand new, but this thing is clearly not new. And so kind of didn't want to spend that much, but they had the make an offer thing, so I made an offer, and they ignored it for the full 48 hours. It's like, really? Of course, in the meantime, I found another one of these, and that was this one. And of course, when you make an offer, if they accept, you commit to it. So I only needed one, so I didn't want to spend, money on an offer that gets accepted, but then, you know, have an offer on something else in the meanwhile. That just didn't make sense. So I waited out that 48 hours and they didn't accept the offer. Whatever, it is what it is. The other sale that I found that had this part made an offer, and I think they accepted it within not even half a day. And I was like, okay, I'm fine with that. They got their money. This thing was dropped in the mail very quickly, and I was very happy to receive it. They accepted a very I think they accepted a nice offer. You know, one thing I noticed about this thing, I noticed when I first compared it to the board, it's like the leads, they match up almost. It's like over the whole length of the thing, it's like they're half a pin wider than they should be, and it's really weird. There we go. They just kind of squeeze in. I gotta see if I got a bolt or a nut that small. I don't know if it's metric or not metric. I might not have one. Oh my goodness, yeah, that's almost massive compared to that bolt. Yeah, I'm gonna have to figure out what on earth that thread is, and Fastenal might carry it. So this is one thing I don't like about this part. The board has to go in at an angle this way and flip up. So I think it's fine though. I don't think it's actually gonna hit anything. 'Cause like you have to come in from that angle to hit anything, and this I could file that down. I've got half a mind to do so right now. just because I can. Good enough. I'm happy with that. I would have preferred it swing the other way, but this is the parts I could get my hands on, so it'll work. I feel like that's a lot looser than it was before. I might take that off and see if I put that on wrong or something, but yeah, I'm feeling pretty good about this. I'm gonna go ahead and solder it. I don't even really need the vise for it. Seems like these ZIF sockets pretty much have a universal design to them. It seems pretty straightforward. Oh, that's interesting. They ensure contact from both sides by having one side cut at this angle, the other side cut at that angle, so that when they touch, there's always a single point that meets. It's kind of an interesting design. It just kind of ensures that, oh, I hope I didn't make a mistake here just now. I think I can still solder this fine. Oh yeah, I got room. It is kind of tight fit, but it works. It's not like the other socket where you literally completely cover it up. Alright. I will mount the board here for that. Those pins are exceptionally fragile, so I don't want to be setting the board down on the pins unless it's into a socket or into foam. You know, interestingly enough, that could be another way to store the things. Just get some proto board, install a few sockets onto it, and then you literally just plug the boards into a board which then is just housed in the container. That could work too. Though foam is simpler and a lot less expensive. I mean, not like these sockets are all that expensive, especially cheap ones. So I have some very small washers, and I will look for, oh, that's interesting. So this connector covers up the hole for this capacitor. That's no problem, because what I will do I will form the leads for this capacitor. I'll just solder it in from the bottom side. Ain't nothing wrong with that. We also don't have to worry about clearance because, as you can see, the sockets are far more depth than the capacitor is. This is what's known as a decoupling capacitor. Its purpose is simply to act as kind of a local energy store. If you think of something like memory, you've got literally potentially millions of bits of data that are turning on and off very rapidly. And every time you turn on a memory cell or a logic gate or whatever, that's drawing a little power from the power supply. Well, there's resistance in every wire, and so the further things are from the main power supply, the less readily available that power may be to those parts. So capacitors store and release energy pretty easily. That's what they're for. They store energy. A capacitor like this, attached across the power supply near a chip or device, basically serves as a temporary, almost like a temporary battery in a sense, where if it needs a little more power than it can get from the power supply at a distance over however long the wiring is, this gives it what it needs in the short term, right then and there. So you'll see lots of circuits have coupling capacitors. If you look at like even the bottom of a CPU, for example, you'll see usually hundreds of small capacitors on the bottom side of the circuit board opposite of the chip. That's just it's for that reason. It's to provide a local, boost of energy to manage those very high frequency changes in state that might cause ripple in the power supply. I just make sure everything is stable and smooth. But yeah, I kind of noticed that before and I didn't actually check it. And sure enough, yeah, most people just put a simple machine socket on there, which is no bigger than these, and so it's not an issue. I found a neat gadget and I decided to buy it, and I will be lucky if I ever use it, but it sure looks cool and I wanted the cool gadget. Okay, there's a bit more metal on these, so you'd make sure they fully heat up so the solder actually properly wets. One benefit with that is it's close to the fan. Getting a little smoke here, and I don't like that. There is a carbon filter and a particle filter on that fan, and it's just meant to catch all the nasty stuff from the soldering iron when it, heats up the solder in the flux. This is actually one of the easier adapter boards to make because there's not really any active devices on here. It's just nothing but sockets and a decoupling capacitor. Alright, last one. That part is done. I do want to make sure that it actually fits on here with the with that extra beefy piece in place. Yeah, that fits just fine. wonder, do I have any machines, specifically machines that I can get? I don't know if I have any memory sockets of that size, or any memory modules that size that I can just grab. I might have a few, I know I have a few machines out in my storage unit, but that's not exactly accessible to me right now. So, yeah, this works great. I'm very happy with how that turned out. Yeah, I just need to get a properly sized thickness bit of foam to go in that case, and that'll be perfect for storing all these adapters. If I wanted to, I've got like 3 or 4 of these things. If I cut out a notch to accommodate adapter boards, I could probably just bolt this thing into one of these boxes. Maybe have just like a little bit of foam up top, spot to put a power supply. That could be interesting. That might actually turn out to be the best way to do this. And these boxes are stackable, so I could just have one box be the tester and one box be the adapters. I kind of like that idea. Alright, I'm gonna put these pins. I've got a bin with pogo pins. Those are close enough to ZIF sockets, so same difference, we'll call it. I'll store them there. It's only 2, but hey, if I ever have one wear out, then I'll have 2 spares. So, I'll take it. Just want to knock some of these out. Just checking the stats on these. Most of them are junk. All right. All right. So that leaves us with 4 more adapter boards. And I think the way to go about these instead of doing them one at a time, I'm going to grab like parts and knock those out on all 4 at once. I think that makes a little more sense. Let's see. So this one gets 0.1 microfarad capacitor. Oh, will this just fit? This works, so I'll just use this. Oh yeah, that's a perfect fit. For these parts, I don't like to put them flush with the board since they're kind of an epoxy dip ceramic thing. So I usually just lift them just a hair up, then to hold them in place I'll bend the leads out. That way, when it hangs underneath, the part won't pull out. It also gives me just enough lead wire to get some strain relief on it. So I'm happy with that. So these two are, this one is the simplest. This one is about the same as that first one we did. This is the one is the most complex one. Just looking over to see if there's anything special I need for it. Doesn't look like it. Just some extra transistors and resistors. So on some of these they do use a diode. In fact, both of these, or 2 of them, will use diodes, so we'll finish this part out. Okay. So it's this one. This gets one right here. And go ahead and pre-trim these, not all the way, but just enough. And this one also gets one. Again, these are diodes, so they do have a right and a wrong way to insert them. They've got to go the right way or they won't work right. I love this cutter. In fact, I can cut a wire this thick and it just doesn't yeet. Okay. .3, 330, 1K, 4.7, 10, 4.71, 3.3, 10, 3.3, 4.7, 1K, 10K. Alright, looks like they all use the same few parts. So these bags must be for something else. So yeah, basically when I bought these parts, I got extras because I wanted to make sure that I wouldn't. I wanted the parts on hand if I wanted to build some of the other adapters that interested me. So there are some extra parts. If I ever get those adapter boards, I will add those parts to the, or I'll have those parts on hand already, basically. So 1, 2, 3, 4, 5 of them. So yeah, I don't even need all these. Like I said, I'm using about half of them because I ordered the extras for adapter boards that I basically don't have yet. Alright. Yeah, these larger style resistors really, I don't think are meant for this spacing of holes. I think this is really meant for those much smaller style resistors. And when I ordered the smaller style ones, but the bill of materials that essentially suggests, you know, here's all the parts you need for it, that bill of materials suggests big resistors. So it was just a case of that's what was in the default order. If I were building it again, I would know better. I would absolutely change those to smaller resistors. I don't like. I say I don't like it. I don't like bending leads that close to the body of a component, but I kind of did that with my diode ROMs for my instrument panel, but that's because I was working with in a space constraint, and I was very careful to bend every lead before soldering in, and I bent them not not against the body, but by clamping and bending, like I'm doing here. That was a terrible bend. Alright, so 4.7. There's actually quite a few of these compared to the other ones. Most of the boards use at least 2 of them instead of just 1. I think this one board uses at least 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So we're using 10 of them. Almost silly to bring this out for so few parts, but why not? Maybe it'll work. I don't know if it's dialed in right or not, but This thing's always fun. This is nothing. What's really satisfying is feeding it one of these. Just a whole spool of parts. It's like a machine gun of productivity going off. So yeah, perfectly formed to go into the holes. Actually, I could have made this, so one of the settings, notice how the wires are kind of fanned out a bit. You can set the tolerances tighter so it'll be more straight like this, but it takes time to dial it in that precisely. And I think I dialed this into the diodes, which had thicker leads, and that's part of why they aren't folding parallel. Part of that is adjusting in for the thickness of the leads, and since these are so thin, they're folding wider because the leads, the machine's set up basically to compress a thicker lead. And since these aren't that thick, they're not compressing all the way, and so they don't fold down to be parallel. So pretty straightforward, but that's also an easy enough fix. And done. Okay, this is the one with a bunch of extra ones. So I just need to make sure they go in the right spots. I say a bunch of extras, it's 2 extra, but you know, whatever. Those are installed. Yeah, it's much easier to just grab all of one part, get it prepared, and then just insert it into a bunch of boards than it is to sit there and do each board one at a time. I wanted to start out with the one board so you know I could more or less focus on the board and not the assembly. So I don't know if these are going on today or not. It depends on, I guess, if they cooperate with the holes or not. I don't really have it in me to do a bunch of filing. I might just do the thing where I take some of these and solder them down there, and then I can literally just have these little pins as platforms, set the part on there and solder it from the side. I might do that because that's going to be a lot easier than filing the sides of the pins down. That is just a downright mess, that. Alright, so what do we got still? 1K. I know a few of these get used. So 1, 2, 3, and 4 and 5. So yeah, it looks like I'm just using 5 here. Let's see. Alright. So I will put these back in their bag. I'm gonna get the others out. Let's see, 3.3. That's 1, 2, 3, 4, and 5. Okay, I have to keep track of them. So this is the 3.3K. This is the 330 ohm. So this uses 1. I think I just used 1 here. Yeah, it looks like it's just using a single 330 ohm resistor. Only one of these boards use the part at all. So I may as well get that one installed. Alright, so that is installed. Again, such overkill, but I don't care. This thing is fun to use. This thing really shows its usefulness when you're doing, like, you know, thousands of these, but even like 5, yes, I could bend these by hand easily, yes. It's just so fun. At some point in time, I want to make that a permanent fixture, like actually bolted down on a platform so I can crank it without, you know, the handle hitting the desk. Don't know where I'll set it up, but I'd like to. Alright, let me remind myself which one these were. So these are the 1K. So these must be the 3.3K. This battery's getting pretty low. Yep. Alright. I don't even know how audible that is, but switched up from Skyrim background to Kerbal Space Program background. because why not? Alright, so alright. Alright. That's the MPSA 06, the 5.6. The 5.6 I believe that's replaced by the 8550. So let's see. 1, 2, 3, 4, 5. Yeah, I find hardware. That's the problem with that clipper. It's it'll bite me too. I felt myself pinching when I didn't close it. Again, I gotta straighten these leads out. so they'll work with this application. Normally these parts would be available with straight leads or formed leads. These preformed ones you use if you have wide-spaced holes in your board, but these are narrow-spaced holes. But because these transistors are end-of-life, there's limited availability of certain forms, so I can get these, but only in this configuration, which is fine. I have to unbend the leads, so no big deal. As much as I love Kerbal Space Program, I've kind of refrained from playing it for the longest time because I've wanted to finish my Kerbal controller. You know? I don't want to get to every part of the game, every planet and moon and everything, and then finish the controller, So I've actually been away from the game for a few years. So this Kerbal music is actually kind of really nice. I haven't heard this for a while. I do kind of miss it. Okay, need 5 of these as well. Of course, these have the unformed leads, so I just plug them right in. think I use up all these capacitors here. So yeah, you saw how this thing launches these. And you can hear it snap. This one though, just buttery smooth. It's kind of crazy how much of a difference there is between those two. It's the exact same brand cutter, but one has a completely different profile cutting edge. So the reason why only these boards use these taller electrolytic capacitors is because of this power supply here. These boards are generating anywhere between 25 and 27 volts as a programming voltage for these very specific EEPROM chips. And so they need a little extra oomph in their power supplies. Alright, so that's all the power supplies components ready to solder. I'll get those headers after the fact. We'll get these soldered first. Just do a real quick check here. much as I like the other cutter. This one has much less chance of damaging the board when using it. And I consider that as good a reason as any to use the other cutter as opposed to the really, really sharp one. Alright, that's 2 down. Excuse me. All right. I will say it's pretty convenient being able to just buy little modules like this and solder them in place. Granted, yeah, this is only what, let's see, 2 capacitors, a diode, a resistor, an inductor, a little 6-pin chip, and a potentiometer. Like, that's not hard to put together. That's not that expensive parts-wise. This is pretty convenient. I mean, it's hard to argue with the convenience factor alone. Of course, that's an odd spacing. I don't know why, but it is. So 6 of these pieces is enough to do one board. 4 for the power module and 2 for the probe leads for adjusting the voltage. So there's a, you just clip like a voltmeter or oscilloscope or something up to that to measure it. Pretty straightforward. Just need to cut up 4 more. That's 2. That's 4. That should be enough. Oh. I literally click the thing to restart the playlist. And after the first song, it asks, "Are you sure you want to continue?" I didn't just manually click it for nothing. Alright. We'll do that last, I think. I don't think I can. No, the holes are not quite right for that. We'll do this. Alright, that worked pretty good. I think I will mimic that technique. Alright, that's another power supply done. Yeah, those modules are kind of convenient. I've certainly got no complaints with them. So like the one board I did, like this one is marked 25 volts. This one is marked 25 to 27. And that's kind of what these adjustment screws are for. You before you ever program a chip using these boards, you basically dial in this power supply. Once that supply is dialed in, then you can use it for programming chips. This board, honestly, or the whole tester platform, it does so many things. It'll be a miracle if I use a tenth of what it can do in my lifetime. But that tenth is still worth it. Maybe I'll use it for more. I don't know. You never know. Third done. One left to go. Oh, this is the weird one. Of course I saved the weird one for last. Alright, power supplies for the adapter boards are done. Quick knock this out. I don't actually care about this connector, so I'm going to do this the easy way. I do not deal with solder wick or braid or any of that business. Oh, where's my plug? There it is. This is the way. Should give it a moment to heat up. And I've showed this off on stream before. This thing is pretty straightforward. It's just a vacuum pump. That vacuum is tied into here. This is spring loaded, and this is easily taken out to clean out the solder. Rubber grommets at each end, make sure it stays sealed, and I'm done. That's completely clear. Well, I could have done a better job on the end one there. It's the ground plane, that's why. So, sometimes the ground planes, they're, attached to a lot more metal. So you have to let the heat sit on there a little longer for them to, for the solder to properly clear out. Alright, and that's done. And my only regret is this thing doesn't have an off switch, so I have to plug it in and unplug it every single time. Which is kind of annoying, actually. But well worth it for the convenience of this thing. I'm going to set it where it can cool down safely. Now, the reason I took that angled connector off is normally it plugs in to the board like this, but I want it to sit flat. And that is why we are going to solder in this connector, because that way it'll plug in like that. Just trying to make sure that this thing doesn't have anything sticking up unnecessarily. I want to have kind of a low, flat profile. Like I said, I'm now considering mounting it inside one of these ESD boxes. So having it be flat is kind of a big deal. And of course that would give me room for packing away like a power supply too, you know. Suppose I could also, that would leave room for probably an adapter board or two, so that's another possibility. Alright, so that should now be able to just socket in like that. And as you can see, it actually sits just below level with the power board. So that works out alright with me. Yeah, I like that. That's perfect. I might put a little block of foam or something under there between the white relays and the bottom of this just to kind of support it a little bit, but this is fine. So yeah, that'll work. I like that. Alright, now the hard part. Will these even fit? If I can get one row at a time to go and use the mechanical force like an awl to shape the hole a bit to be a little more accommodating. Yeah, I can force these all the way through. No problem. That's fine. Because every time they get forced in, they're basically kind of reshaping the holes a little bit each time. So then if I push that through again, it goes in easier. Yeah, I think this is going to work all right. I think this will work out just fine. Before I filed these down to where they'd fit more easily, but doing it this way, we're just kind of we're basically gouging out the corners of the round holes and the corners of the pins so that they kind of just eventually fit each other. they're going in a lot easier now. That one didn't even so there's some vertical play to these. The pins will move up and down. One of those actually went in without even pushing through on that whole vertical play thing, which means that that socket was actually almost loose. So yeah, this actually works just fine. I was really concerned that we wouldn't be able to fit these, but this seems to be the trick. Just mounting these one at a time, inserting and removing them until they sort of force the holes into shape. Yeah, this works. This works just fine. Might be a little hard pushing both sides through together when I'm doing the actual assembly, but I think this will work. Yeah, I was actually really worried about this, and this is kind of ending up being something that there's really nothing to worry about. It's just a little bit of extra effort beforehand. Nothing too inconvenient. All right. Alright, so that will hold everything straight, and all I gotta do is get some corners soldered. There's a nice thing with these socket pins. They fit into each other, so you can kind of stack them like this, and they sort of hold each other in alignment. Of course, once you got the two ends soldered, I suppose I can kick this back out since I'm done with the SD card module. You know, there's actually, interestingly enough, there's a Wi-Fi module that exists that will actually, it plugs into the SD card socket. Like, not the socket on the board, but the actual SD card socket. And apparently the firmware on this thing is programmed to recognize that. So, in theory, instead of loading ROMs onto and off of an SD card all the time, you could, in theory, set up basically like a shared folder on your computer, and then your computer would connect over Wi-Fi to that SD card socket, and that folder on your computer essentially would then look like an SD card, you know? like it was its own drive. And that's actually like super convenient. I'm very tempted to find one of those modules and plug it in and never have to worry about an SD card. It's not like I ever really turned my computer off anyway. I suppose I could keep an SD card around with the ROM checksum database, for example. That's, at least still good for testing, stuff, even if you're kind of not home. That's the other thing about this thing I learned. That thing will absolutely run off of a USB power bank. Although now, I kind of wish I would have just went ahead and splurged for the power board option 3. I kind of misunderstood the descriptions. Everything was originally done in German and then translated to English, and I kind of didn't quite get the implication. It sounded like the power board options existed as well, you need this for testing these chips, you need that for testing those chips, and in reality, the option 3 power board is just compatible with more of a wide range of input sources, including sources that are below 5 volts. So you could even run it off of a cheap USB power bank that doesn't even put out a solid 5 volts. That's kind of neat, actually. And I wish I'd have realized that, like, the option 3 power board basically requires you buy an additional, DC-DC converter module. I think it's like $12. Like, it's $12. I don't care about $12. I would have bought that. So yeah, I'm thinking I might try to source one of those and install that instead of the one that's on there right now. Because this module, while it absolutely runs off of USB. Like, I've plugged this into a USB brick and powered it off of that. The thing is, it needs 5 volts at the USB input for it to generate a full 5 volts on the output. If the USB is even slightly below the full 5 volts, it won't be able to generate the right voltage levels. Instead of these two linear regulators, it uses a second one of these DC converter modules, and it does the exact same thing as this, just with more precision and a wider range of voltage inputs, including the ability to boost the input voltage. So if it's like, say, 4.5 volts or 4.8, it can boost that to 5. And I wish I'd have better understood that detail when I ordered that thing. It's not a big deal, It's probably like $15 worth of parts that I put into that power module, and I'd probably be putting $25 or $30 into a new module, I'm guessing. So it's not a big deal. I just wish I'd have realized from the start. Like, I thought it was, I'll never need this, So it was just kind of a misunderstanding. I didn't really get what they were trying to offer out of it. So yeah, there's a little bit of misalignment. I'm trying to get both sets to go in Nothing too big, nothing we didn't figure out with the other one. Come on. Go in the hole. It's your home. Oh, for goodness sakes. Okay, that is getting a little frustrating. Just does not want to go in the hole for some reason. I mean, the reason is because it's way too big for the hole, but you can get one side to go in, like, perfectly fine. I'm gonna try something. That was enough to do it, but we'll try. Oh, I did it. There we go. It's in. I can hardly believe that fit. just pushing down the sockets, because they're kind of pushed pretty far up right now because of how tight everything is. And I got another one that's warped. Try to fix that one by unscrewing the top like I did before. So I can see why these are cheaper. They're not the greatest ZIF sockets. They've got their problems. But they're at least serviceable. That's, you know, important. I can pop these open and actually work on them, you know. If there was no way to do that, then that would be an issue. Just making sure that these are all pushed in to the proper depth, the way they should be. Then are a little hard to put back together. So what happens is when you push this lever, it pushes this whole bar over and it pinches them, but the back piece is supposed to brace up against that. And the problem is that when it's open, they don't want to brace up against anything because they're kind of all the way back. Because there's alignment pegs, I can't just push it back and then slide it forward. It's actually really finicky. Okay, if I hold that like that, okay, here we go. This might work. I think that's what's happening here. Ow. Maybe this frustrating. Does this lift at all? Okay. I'm starting that screw. Because really? There we go. So what happens is, the way this works is, when you flip this lever, it pushes this middle rack this way, and it squeezes the half of the socket on this side towards this side. Well, the half of the socket on this side is braced up against the top. So with the top off, it springs all the way over. That's why it's hard to put back on. But it looks like if I run the X-Acto through that gap, I can basically bring all the socket connections where they need to go. All right, that is good. Point that way. All right, I am happy with that. I'm going to solder it. I really wasn't sure these ZIF sockets were gonna work out for me due to the size of the pins and the small size of the holes in the board, and even getting them to physically fit. Yeah, it seems these sockets are a little easy to damage if you're kind of forcing on them, but it's easy enough to fix it too, you know? So, lesson learned, just pay the extra for the name brand and not the knockoffs. These say text tool on them, and I 100% guarantee they are not text tool ZIF sockets. These came from the finest markets of the Far East. So I am paying for their price by having to fiddle with them more. Granted, I got 6 of them for about the price of 2 of the proper name brand ones. So it was a significant savings. Maybe only 1.5 even. They were pretty cheap. We'll just put it that way. Alright, that is done. Probably give her a quick scrub here. I'll do the washing after the fact. Let's see. All the sockets are actuating properly. Excellent. That's what I want to see. You know, nice thing with the ZIF sockets in place is they're heavy enough these things actually sit naturally. They don't tip over like a certain Commodore cartridge does. I actually got an extra one of these sockets because there was something I was gonna make one of the other adapters I wanted to order, but I only have need for 3 of them, so I'm gonna put one of these away because I don't need it. I had a socket holder somewhere around here, but I'll deal with that later. So again, just kind of inserting and removing the pins from the sockets repeatedly. I'm just doing this to kind of where there. I suppose just imagine, if this is the hole, the pad around it, trying to just kind of warp the corners a bit out like that, because the pins are very rectangular, and so I'm just trying to warp these corners a bit, kind of digging a little into the metal, digging a little into the fiberglass of the board. Technically it's damage, but it's the right kind of damage. It's the damage that makes things actually work, and we're okay with that. Oh yeah, that was the complicated. That was the more complex power supply we just put together. So, cool. So now, the other side. I actually want to kind of warp the edge of this more so than anything, because I want it to go in easier. And I'm hoping that doing that will make it go in easier. Okay, I'm liking that. It does seem that the process of forcing these pins does seem to cause some of these to warp out. And I think that's simply because the pins basically, you got the two sides, then they bend together, and then they go down to the pin. They're actually a loop at the end of the pin. And so any warping that happens there can kind of flex the pin higher up. So I think that's what's happening here. Actually, all of these kind of got a little bent. I don't much care for that. I mean, ideally, we want it to just fit, but, you know, Hey, that actually went in. Yeah, it seems... Yeah. Messing with the pins when it's in the locked position seems to really make the warping of the socket. It's pretty bad. So... That, or maybe they're just so cheap that they warp from being in the locked position for a while. I mean, they're better than not having them at all. But I will definitely have to reevaluate the cheap ZIF sockets in the future. They're not great. The electric tape holding the iPhone 6S is coming loose, so I had to adjust the camera. Yeah, so one of the things I looked into, obviously trying to find a camera on a budget here, but I found some interesting cameras on AliExpress that claim to be suited for kind of line monitoring. Essentially, they're supposed to be 4K 60 frame per second cameras. There's no audio in them, I don't think, which doesn't matter, you know, you can just have a microphone. In fact, that's a project I've been thinking about. There's a really nice DIY microphone that could be made for pretty cheap, and I kind of want to just buy the parts and order that, you know? It'd be nice to have just, you know, here's my microphone, I made it, you know? That'd be kind of cool. So the other thing I'm kind of contemplating is, you know, the vision ain't so great these days. If I want to look at things up close, it pretty much, I'm looking over the edge of my glasses here. And it'd be nice to just have a kind of a microscope view. Something where I can zoom in on work and see it really clearly, you know? Alright, it's in. Oh wow, that really pushed through. So that's kind of what I need to be careful of. Oh, that's not in. That's the problem. It just straight up pushed through completely. That's alright. I gotta take this apart anyway. And I found that when it's loose, I can very easily put each individual pin into the hole. So this should go together without any trouble. Just gotta that really folded over. That's yikes. So that didn't just not go through, that actually kind of folded up inside the thing. Like, I could fix it. It's simple. But yeah, that was, it did not like that. Alright, so yeah, it's pretty straightforward to fix these sockets when they get warped like this. It does seem forcing them in like this does ultimately kind of warp them. But that's fine because it can be fixed. Honestly, it would almost be easier to just take these apart and insert them pin by pin. That's still a lot of work. This one's still not quite right. This is the one that heavily warped. There we go. Given how many warped on this one, maybe I'll just try that for the next one. Just pop all the pins and insert them one at a time. Because this thing seriously got warped. Alright. How does that look? I don't know why these ones are catching so badly, but once they let go, they're fine. I'm going to try this one because I know this one worked well. I don't know if it makes a difference or not, but Alright, that's perfect. I actually thought I'd mess something up, but it's actually, everything is so perfectly lined up that I wasn't even seeing the movable half the socket. It was just perfectly lined up underneath the edge of the opening. That actually seems to work. Alright. And I am not going to leave these in the tight position anymore, because it seems like they don't like that. So yeah, I'm happy with that. So let's try this. Just take it apart and insert the pins. See how that goes. Of course, first I gotta mount these. Well, I bet one of the pins completely accidentally, not the piece I'm trying to solder, but the pieces I'm using to secure them. I'm going to go ahead and knock out both boards for these pins. What? What? Oh no. I made a grave error. Apparently I spaced those one segment too wide. Oops. Yeah, I really messed that one up. Yeah, let's not do that again. I'm quite frankly amazed this didn't warp worse. Like that pen's bent just a little. I'm kind of shocked when I realized what I did there. So what I did, instead of putting pins 1, 2, 3, 4, 5, 6, 7 apart, I put them 8 apart. And so they were splayed out like that. Oop. And then I put them on the wrong side of the board anyway. Oh my gosh. How long have I been soldering? 6 hours. I'm gonna finish this up and call it a night. I am so close to done. I'm gonna finish this. Ah, toasty. Okay. Oh no. Oh, that did it. Sometimes a little inertia is the only thing you need to clear out a bad soldered joint. That's... I was wondering why... I noticed when I had it on the wrong side that the potentiometer was keeping it from sitting flat. I was wondering why it wasn't sitting flat. That was why. It was upside down. really put that one through the ringer. So I also kind of took a gamble. I'm already soldering this, and I haven't even tried to pre-shape or form the holes. So I'm just kind of going off the, I'm going to try this new thing, and it's just going to work mentality, and good luck me. Suppose I'm also forgetting to clean these. I should probably do that. As well. All right. so verdict is they don't just easily push through, so we still need to do the preforming. So I'm going to pop this back off. They start, they're not going any further. And of course, the thing is, there's no preforming. So they're kind of so I will do that now. I think once we do the preforming of the hole, then it'll be much easier I wish I had a tool to just do this. I hate putting strain on the actual, Oh, this one's especially tight. I was not expecting that. Holy cows. Yeah, this one is pretty much extra tight. Like, none of them have been this tight, so yeah. That's kind of nuts. Yeah. I think when we're flexing the bases of these these pins, when it's in the lock position, it's kind of warping the actual socket contacts. Yikes. Yeah, this one is super tight. Like, concerningly so. That's kind of nuts. my goodness. Yeah, this kind of sucks. Oh, hey. Just hour 6 of putting together adapter boards for my retro chip tester. So what we did so far is I modified this SD card module so it lays flat instead of sticks straight up. Let's see. Oh my gosh, my bits. And then these are done. Yep, made in Germany. Oh, let's see. I'll pop a link. Let's see. Alright, so that's the board. So this is kind of a universal, is it digital logic? Then yes, it tests it. But yeah, let me, so this here, these are some, I forget the number, HCMS-2003. These are little dot matrix displays. They're actually green instead of the more common red. These were near unobtainium. I did get them though, and I've not yet tested them. I hope they work. Boy, I hope they work. because I spent about $25 a piece on them. But what they are, they're a 70s era LED display chip that it was mostly used with, like, you know, aviation, military, scientific instruments, stuff like that. One of the things they were used for were the displays in the Hewlett-Packard HP 9825. And that calculator, it's really a computer. But back in 1976, people, like, if you wanted to request your boss or supervisor or, you know, whatever agency you worked for, that you wanted a personal computer, that was absurd, and you had to jump through all sorts of red tape to requisition a computer. Calculator, on the other hand, there's all sorts of specialty calculators being made during that era for, you know, statistics and, you know, all sorts of stuff. My brain is literally blanking out on me because I've been streaming for 6 hours. But what Hewlett-Packard figured out was it was easier to just call the thing a calculator and just lie about it being a computer. Any engineer who knew what was what knew exactly what they were getting, and their bosses were none the wiser. So this HP 9825 has these red LED displays, and I just want to put green ones in mine. I want to see how that looks. I think that'd be really cool. So that's why I bought these. No other reason, just that. So there's the 9825 is actually kind of an interesting machine. It was a 16-bit 10 megahertz desktop computer about the size of an Apple II. Instead of connecting to a monitor, it had a single line LED display, but you could plug in expansions into it, all that sort of stuff. That was in 1976. 16 bits at 10 megahertz was kind of a big deal in 76. It also cost like 5-digit price tag back then too, so they were not cheap. All right. How's the screen look? All right, cool. So the way this thing works, there's a microcontroller underneath the screen. I love this screen. It's an OLED panel. Well worth it. So there's a microcontroller running everything. It's an Atmega 2560. This is the power supply area. This is generating 5 volts, negative 5 volts. And then this module is generating plus and minus 12 volts. There's breakouts here for all the power supplies. If I unplug this SD card adapter, you can see there's a pair of relays and this chip here. This chip is basically kind of a solid state relay, but what those chips are doing in the relays is they're selecting different power supply rails and then routing them to different pins. All the transistors here and the resistors and diodes and whatnot, these are selecting certain outputs to send to certain pins, telling whether those should go high or low or be open. And then all these resistors and diodes here, they are literally connected to every pin so that they can monitor what's happening on every pin of the chip. And what this is going to do, so this can test SRAMs, dynamic RAMs, first in, first out, which is a very old style of memory. Instead of being random access like what we think of today, where you address a location in memory, these were basically just a bunch of memory cells in a chain. When you fed data into one, the data from the previous memory cell would bump to the next one. And so in order to read data, you had to like wait for its turn to go through like a bucket brigade kind of thing. This will test those. It'll test EPROMs, ROMs, PROMs, you name it. Logic chips. I just happen to have a 74HC154. So if I put that in the socket, select logic, it's got a bunch of different ranges, so 74, 300 and up, 600 and up, 75,000 series, 4,000, 45, bunch of miscellaneous stuff. Soviet chips. It has a PAL analyzer. Yeah, it is serial memory, exactly. A lot of old machines back in the late 60s, early 70s, instead of having all the bits in parallel like we have with like an 8-bit, 16-bit, and so on computer, they would have 1-bit serial processors. So you'd load a bit at a time in serial into the processor, and that was just how it was designed. It was, the timing on these things just melts my brain. But yeah, the PAL analyzer, the way that one works is you tell it which pins are inputs, which are outputs, which is your power, which are not used, and it will then go through and cycle through all the different possible combinations of inputs, and it'll record the outputs that you get from it. PAL chips, it's I think that's programmable array logic, something like that. And what they are is, it's kind of like a miniature FPGA, where you have a bunch of general logic in kind of a matrix. And what you do is you program your particular logic configuration onto the chip, and it's burned into it permanently. I mean, I think with PALs it's permanent. GALs might be rewritable. I'm not sure the details on it, but they work more or less similarly. It's kind of like a very small scale FPGA. Of course, companies that use them will often write the flag that says that you can't read them out, but this thing will work out the logic through analysis, which is kind of neat. There's an identification mode. So say you have a device that's got the part number lasered or filed off. Yeah, basically they're kind of you buy the generic PAL chip, and then you can configure the logic to be whatever you want to set it up as. They're really cool chips. Really good for like eliminating lots of glue logic, So the identify chip, this is good. Like say you have a part out of a machine that has the part number lasered off or something. You could potentially identify the chip by using this mode. I didn't want that. There's a joystick adapter that you can use to test joysticks with. Apparently this mode is for testing like LED matrices. There's a clock generator, a frequency counter. Those require adapter boards I don't have, and I'm actually very tempted to get them. But yeah, so back to the 7400 series logic. If you hold the button down, it'll accelerate. Alright, so a 74154, that's a 4 to 16 decoder. If I hit OK, it'll run through, check the chip, it's good. So you'll notice there's a power light here, power light there, and a bunch there. So this is just the main power. This is the power module power. Then these are the individual supplies, so 12, 5, and -5. This light, you'll notice it only comes on when it's under test. So when it's not testing, there's nothing connected here. So if I pick up the chip and drop it in the wrong slots, I'm not going to blow anything up. There's no power there. This light only comes on when there's power, and that's just activity for whenever the processor is doing something. Now, I've got all these little adapter modules. So this one, if I put this in, this will let me plug in a Commodore 64 cartridge. Alright. And this switch just selects the high and the low bank. Let's see. This is actually the first module I completed today. I'm realizing that has some heft to it. So what this is an EEPROM programmer, and exactly, this cannot just test chips, it can dump and it can write. So this is an EEPROM programmer, it's a dumper. This memory card, when it's installed, if I hold the OK button down when I select the chip type, if it's like a ROM or an EEPROM or something, I can hit OK. Oh, okay, so you see it failed because the chip's out. It's kind of interesting. So yeah, it kind of tells you which pins it even failed on. But yeah, so if I was to plug this in, and if I had the right EEPROM to plug into there, the way this thing works is this does the ±5, ±12, but like some EEPROMs have programming voltages upwards of like 25, 27 volts. And that's what this is. This is a boost converter. So it's taking the 12 volts and boosting it up to between 25 and 27. It's adjustable with this potentiometer. There's a ground and a measurement here, so you can actually measure what that voltage is. You can adjust it in, and once it's good to go, these transistors can then switch that voltage in, and you can program these higher voltage EEPROMs. So it's kind of a neat setup. And I just went ahead and bought the programming adapter kit, so I'd have it. I don't know that I'll ever need all of them, but I'm just building them because you never know when you run into a particular model EEPROM. You know, if you're working on some old machine, you know. This is the 30-pin memory adapter. Oh, yeah. I really need to get my seating situation figured out for my computer desk. I built a brand new computer desk from scratch. Where's my pictures? Go. And that's exactly what it is. It's a 30-pin SIM slot, and that was actually pretty common back in the 386 era. A lot of old Macs used that too. Some other machines, I think some Ataris. Actually, this one here, this is a 30-pin SIP socket, a zero insertion force socket, no less. I didn't know these sockets existed until just recently. Basically, This is the exact same thing as this, except it has actual pins like this instead of being the card edge connector. So you'd have like a socket on your motherboard and the memory would just plug in, you know. And that is why it has the power off. But yeah, so this will test both the single inline package and the single inline memory modules. So they're both electrically the same. And that link that I dropped in there, that's my computer desk that I built. The console, yeah, these sockets are really neat. This is like the brand name one. These ones are all Chinese knockoff ones that I got off AliExpress because I wasn't building 5 of these circuit boards with what one of these cost. The main one, I gave it a good one. But yeah, part of the problem, and it's kind of where you jumped in and where I left off, the holes in the circuit boards are smaller than the pins of these cheap sockets. And so I've been kind of just working them, trying to force the hole to widen a little bit by, you know, brute force. Not ideal, but it's worked for 3 of them so far. And I finally run into one where the board is just really, really tight and is not cooperating well with me. But yeah, so that's a thing. Anyway, yeah, that retro chip tester is, I like it. I think it's going to be a really useful device to have around for troubleshooting and whatnot. And I'm glad I'm putting the effort in now to build this up, because if I ever need it for any particular task, you know, I want to have it here. See, I've had one of these little guys for years. I love these things. Some people kind of, you know, don't think they're all that great, but the thing is, I like it as a sanity check. Alright, so it's approximately 100 nanofarad capacitor. That's what this should be. That's what I expect it to be. It's nice to just have confirmation that's the right thing. This diode, or not this resistor. Why did I say diode? What is the value of that? Sure, I could look at it and try to squint at the color bands. This is 466. It's approximately a 470 ohm resistor, and that's what it's supposed to be. It's a 470 ohm resistor. Transistors, I really like this for verifying the pinout of transistors. I've run into it before where you buy a transistor from one manufacturer and you buy it from another, and they have different pinouts for the collector, emitter, and base. You know, and it's annoying because you have to go and look up a data sheet for that manufacturer, verify that everything's right, that it matches your board. If it doesn't, you need to reorient the pins so they work. Or I pop out that little tester, press a button, and oh, okay, they're arranged that way. And I can just sanity check that way. And I've found that to be so useful. So I've got the pins, they're going in, but they're not going all the way through. And, oh, this is infuriating. This may end up being a sacrificial ZIF socket, because I did buy an extra one because there was another adapter board that I don't actually have that I really want to build now that I've seen it. And so I bought the extra. Let's see. Oh yeah. I should grab my keyboard. I'll be right back. Alright, sorry for that delay. Oh, it's a little dusty. So, this... I actually need to do a little service on this thing, to be honest with you. But this is my... Oh gosh, I really need to grab the duster. There's all sorts of dust between the keys. So these keycaps are Danger Zone. I built this keyboard from scratch. It's just literally oak trim. I had the plate. I just launched my alcohol brush all over me. Thank you. So it's literally just half-inch oak trim. I did all this with hand tools. The edge of this thing, it's got Gateron blues, and it's the old style ones. I don't know if you can see that. It's the old ones that had the frosty tops, and I actually took every switch apart and dyed the tops blue. Because why not? So yeah, the other thing I did was I trimmed all the nubs of the bottom row of keys, including shaving the cap for the center post so that it was flush with the bottom of the key bottoming out, just to get it thin. The total thickness of this keyboard is less than a centimeter. Like, I'm happy with how that turned out. And I call this a 76%. It's basically a 75%, but I added one additional row of keys so that a normal shift can be used here and you can still get your arrows. It's all hand wired and laced. Yes, all hand wired, and I have little amber LEDs put into each switch. I didn't want like crazy RGB, but I wanted something like amber, something real subtle, kind of like, you know, an instrument panel of an aircraft or something. And magnetically attachable number pad. That is my favorite part. Okay, yeah. No, I make myself do terrible things to myself, and all of them involve a soldering iron. But yeah, I really like this feature. So what this actually is, this is a USB-C MagSafe type connector. It has, oh gosh, it's got 20 conductors, and I literally just have the matrix extended through these conductors, along with the PWM pin for the lighting, as well as power and ground for the lighting. But yeah, all that's through that one connector. There's no microcontroller in this side. It's all just straight up brute force wired into the matrix on this side, so there's no glitching when it disconnects or connects. It's just cross row and column through that connector. And I embedded some magnets into there and there. This is magnetic as well. There's actually a tiny little power LED right there. Funny thing is, I was going to use a serial interface for this, but I just always had issues with the disconnection and reconnection part. And so I'm like, you know what? Now that there's connectors big enough with enough pins, I'm just going to brute force this. So it's just an extension of the matrix wired into this, and it's glitchless. It's completely glitchless that way. But the old connector had a little nub there, and I had to fill it in, so I just took a piece of plastic, put an LED behind it. There we go. I fixed it, don't worry. Yeah. So, and again, that's just a little amber LED right there. I'm very happy with this keyboard. I need to program certain keys to actually do anything. It's been kind of on the back burner because one of the issues I had was when I changed over to this with this new connector, I kind of screwed up my backlighting circuit, so I gotta fix that. But yeah, I'm pretty happy with that thing, how it turned out. But yeah, I love the magnetic connector on that. It's just different. I like that. Let's see. Yeah. Pogo pins, they can be nice, but they can also be a hassle. I like this one because it's kept on the side, so it's never dangling or dragging in, floor, dirt, whatever. So it generally stays pretty clean. And then it does have the other magnets keeping it stable. There's actually indexing happening here too. These magnets actually stick out about 1 millimeter, whereas these are recessed about 1 millimeter in. And then likewise, this is recessed and that sticks out. So when this locks, I can literally twist the whole, it's a strong connection. So I'm pretty happy with how that turned out. Oh, well, you will have to tell me this. Sounds like an angry mouse. Yeah, this extra ZIF socket may end up being a sacrificial ZIF socket. Basically, I'm trying to force the socket to insert. I'm basically using it as kind of an awl to remount the holes here. And yeah, I mean, this has worked perfectly fine on all 3 of the ones I did before. And now, of course, it's choosing to be a pain. But the more I work the square peg through the round hole, the less of a round hole the round hole becomes. And it starts to adapt and change and become the square hole. At least that's the goal. Yeah, I'm at the point where I don't care if I break this ZIF socket. I think it cost me like $2. So I will just use this as a tool for adapting boards to accommodate it. I've got one more here to install. These 2 are done. So you can see this one has a slightly more complex power supply. This one is a more basic one. And they all pretty much work the same way. In this case, you adjust either 25 volts or 21 volts depending on the chip you're testing. This one, this one's 25. This one's 25 to 27. This one is 25. Okay. Oh yeah. There's a streamer I watch who had a Vive, and their controller was charging. When they went to grab it, they burned themselves because the USB cable had become hot because something had shorted out inside the controller, and when that cable brushed up against them when they were going to pull it out, it was hot enough to burn them. And of course, the controller was dead. It was shorted, but yeah, like USB. Yeah, no kidding. Between the amount of power that modern USB can put out and lithium batteries, like, that's not something to ignore if it, yeah. Alright, it's so close here. Yeah, it's kind of nuts. Man, this thing is stubborn. Oh, I'm a little frustrated that I'm stuck on this one stupid thing here instead of actually making some progress. What did I just do? Okay. Yeah. And I suppose there's Thunderbolt 2. I think I've seen some crazy charging through those as well, like connecting through docks and such to laptops, It's kind of wild. Man, there's just no way to get that from the other end. See, I mean, I could, but I don't want to, tear through the through-hole plating. I'm fine deforming it. I just don't want to tear through it, This is the end that's giving me trouble. Ugh. Come on. Yeah, I am so gonna mess this ZIF socket up if I keep pushing on it, but... Oh, interesting. Alright. Maybe it's not so... Got a little bit of... Okay. It is... Excuse me. Oh my gosh, it's 11:36 p.m. here. I have not been keeping track of the clock. I suppose 7 hours streaming. I started at around 4. The other ones went pretty fast, and if this went at the speed of the other ones, I'd have this one done. Okay. I mean, not the most ideal. Alright. Hey, thanks for stopping in. You have a good day. I will keep on working on this in the meanwhile. Hopefully the next one ain't so bad. Just want to warp these holes enough to where they'll actually go through here. Oh, I bent this. Bummer. Gotta be a little more careful here. Okay. Is this a good sign, maybe? It's enough of a sign that I'll take it. Alright, now how bad is the other row gonna be? Alright, so I actually got the one side to work just fine. I'm trying to get the other side to go into the hole. I think it's starting to go. Oh yeah, it's starting to go. Oh my gosh, that went so much further. Oh boy. Which means this needs to go a lot more. Okay, this is working. Just push each one in one at a time. Seems to be enough to get it to go through. Those all went through. Okay, is this even working? Ugh. Of course, if it's not one thing, it's another. I'm not sure. This. Okay, yeah, it's really, really heavily sprung backwards. Is this like that? Well, I know why. It's because this isn't on and every one of those springs is fresh. It hasn't been warped like every other one has. So, presumably, assemble this. Yeah, that's why it's springing back. It's all these back springs that
clipping like that?
Oh, shoot. It's in. Good. Which one was it beating up? Oh, definitely this one. My goodness, that's warped. Funny how the warp happened at the same ones. Okay, so that's the one I'm preserving. See if we snagged anything good. That's too big. this is definitely a sacrificial ZIF socket. That thing got absolutely trashed, and it is definitely in no condition to be used. So I'm kind of glad it's a cheap socket. I hate to drill out the plated through hole, but it looks like I kind of don't have a choice. These things are just way too tight, and it does look like 100% of the connections are on the bottom, so it's justifiable. Like, I'm not breaking any connections doing this. But yeah, it's kind of a final resort here. How does that look? I'd absolutely consider using the Dremel, except it is midnight. And I don't think the neighbors would appreciate it. But this is doing the job. I've got a feeling it'll work just fine. If there were connections on the other side of the board, I'd be more concerned about doing this. But literally, every connection is right here on this side of the board. Like literally every connection. So if this is the side I'm going to be soldering on, I'm okay with that. Trying to avoid doing this because I didn't want to drill out the plated through hole, but this really is the best option. At least with this board, it's fine. There might have been wiring on the top side on some of the other boards. I don't know. I didn't really look. Let's see. That, and I suppose hand drilling it is a little easier on it than 10,000 RPMs. It's a little slower and it's not as fun. But yeah, I suppose between not bugging the neighbors at midnight and not stripping out the circuit board, there are benefits. This hole, we'll mark 3/4 done with this. And I can finally finish up soldering here. What's annoying is I've actually got like a pin vise. Basically, it's a tiny little chuck with a little thing that you can hold the top that spins. It's basically a hand drill for really tiny things. And it's a lot more comfortable than holding on to this actual chuck. And I buried it in with some of my other tools and I don't know where I put it. I'll probably find it as soon as I finish streaming. That's just how that goes. Alright, last one. Yeah, for whatever reason, these two boards or these last two ZIF sockets, either one, maybe it's a combination of both, these ones wouldn't cooperate. The other boards worked fine, the other three, but these two, for whatever reason, just refused to cooperate. Okay, so far so good. That works. Now these. So this is just 99% isopropyl, and it I use it to clean the flux off these boards. Gets them pretty clean. is done. And just gotta solder this one. That one still ended up a little bit warped, and I'm wondering maybe it's hitting the pin while it's in the closed state. I mean, could be. This one is left open. The lever is sticking straight up. It's just hanging over the edge of the workbench here. See if that has any effect. All right. I think that's a little better. I think these cheaper ones are just cheaper. I mean, ultimately, I think that's what it comes down to. But I'm happy with the progress. Just gonna clean these up here. I'm glad I looked at this again. It's not soldered. Huh. Well, that's soldered. soldered. Alright. I think I'm gonna transplant these. Oof, yeah, some of these are definitely salvage. They are rough. And there's still literally solder and uneven pins on that one. Yeah. I mean, I kind of knew what I was expecting with these. They are pretty much unobtainium, so I'm just glad I've got them. Oh, I just realized if I use that box to store these in, I may have to store them in the closed position, which I'd rather not do, given how I've seen the proclivity towards warping of the socket contacts when they're closed. I don't know. We'll see. it's actually got room. That is not room. That is also not room. Also not room. Cabooses. Caboose? Okay. Yeah, this is getting ridiculous. Okay, that's awful. Jeez. Well, I guess we'll just share a bin with this. Just getting the screenshots or photos of the finished parts. Alright. How'd that quit? Alright. Now, I think what I'll do yeah, that'll work. I don't need to close this box or anything. I'll just set that aside. Until I get a better storage solution for these, this'll work to protect the pins and keep everything organized. So, pretty happy with that. Oh, so yeah, this has gone quite well. Alright. So, I am pretty happy with the results of all this. Let's see. So, I don't think I can put this in here quite yet. As it stands, I think the LEDs and these capacitors sit too tall for it to properly close. That's fine, you know. I can always get shorter standoffs or even make accommodation holes in the case for all I care. So Alright. I think I'm going to end the stream here. So that was an interesting bit of building. I might have some more of these adapter modules in the future. But I think for now this will cover most of what I'm going to do with this for now. This is just going to be a tool that I use with other projects mostly. Getting this SD card loaded, that's going to be a big deal. Having the ROM database, with all the checksums, stuff like that makes it really easy to troubleshoot things. So I think I'm going to call it then. I think next time around I might do a bit of soldering for work. So probably some more hall boards. Maybe I'll sit down and work on some of these solar LED modules. Those really need to get done. So alright. Oh, I see. I just see someone joined here. I am finishing up here. I do apologize for that, but I mean, feel free to skim through the VOD if you like. I usually post my videos up on YouTube afterwards, so feel free to check that out. I try to get in here on Saturdays, do something or other. I don't know what next week will be like. I've got a lot of stuff planned for that. We'll see what happens. So I suppose good night.